Okay, hey everybody, this is Mr. Bells again. How are you? Um, there are two other sections to the trigonometry that we wanted you guys to be able to cover, or need you to be able to cover in this class to be able to still get credit. And that was a law of sines worksheet, which is right here, and then a law of cosines worksheet, which is right here. And what I'm going to do is I'm going to just pick some of these ones. You'll see that these documents you can get, they're called handouts, on the list of all of the things where your videos were that I put in the Google Classroom a long time ago, where all of those are, or the fact that I'll probably put it in a link in the email that I'm sending out with this too. Okay, so what the heck are law of sines and law of cosines? Law of cosines will be the next one. We'll get to that in a little bit. Law of sines worksheet basically deals with any triangle. Okay, so any triangle that we have, three-sided figure, we can go ahead and use something called the law of sines to be able to find out some information. Now, the law of cosines also works for any triangle too, and what I'm trying to say is we use SOHCAHTOA, sine, cosine, and tangent, for right triangles. So all of these triangles could be used if they had right angles in them, but they also work when they don't have right angles. And SOHCAHTOA only works for right triangles. Okay, so first off, I need you to be able to copy down what these two laws are. So here we go. So the law of sines, and the reason why we need both of these is because they work for specific types of triangles. States that sine of an angle over its side equals sine of an angle over its side opposite equals the sine of an angle over its side opposite. So sine of A over little a, sine of B over little b, sine of C over little c. Whereas any of these triangles that we're looking at right now, if this is angle A, then the side opposite it is little a. And if this is angle B right here, referring to this amount of opening right here, right, just like that's angle A, then little b is over here. And if this is angle C, which is referred to this amount of opening, then that's little c right over there. Okay, and it's just ratios, so we're solving proportions with this. And the law of cosines, I'm going to go ahead and run it in here right now, is a bigger one, and it looks like this. That it's got a little Pythagorean theorem in it that says that a side squared is equal to another side squared plus the other side squared, kind of like Pythagorean theorem, right? But then there's more to it because it doesn't work for a right angle. Minus 2 times b times c times the cosine, and that's pretty important where we get that from, times the cosine of the angle. And this has to match up. If this is angle A, you have to have a little a here. If this was angle B, this would be little a, or excuse me, if this was angle B, this would be little b. If this was angle C, this would be little c. So those two letters have to match up, and then these ones are the ones that are left over in there, okay? And how and where does it work? So when I'm given triangles and I have something like this, maybe I have a 3, a 4, and a 5 for the lengths of this triangle, and I want to know, hey, how big is that angle if I have these 3 lengths put together like that? Well, I can use the law of sines for that because I have side, side, and side. Okay, so law of cosines works when we have a side, side, side. The other situation where it works is maybe I have this, this is 10 and this is 12 and this is 96 degrees. So I have a side and an angle directly between those. Okay, so if I have either of these two markings on my triangles, SSS or SAS, I'm going to use something called the law of cosines. And I'm like, okay, so what allows me to figure out some of those other things? Okay, so back up here in the law of sines. Law of sines, you can see that in order to do a ratio, I have 1, 2, 3, 4 variables, right? I got to know 3 of those 4 variables. So I could do it with this. Here we go. Let's say that I had this triangle right here, and this was 5, and this was 50 degrees, and this was, say, 7. And I wanted to know what this angle was right here, what this dot was. You can see that I've got one pair right here, just like that, right? And then I've got another pair right there. And I only have one of those variables, this dot, that I don't know. Okay, so then I would have 3 out of the 4 things that I would need. And I would write sine 50 over 5 equals sine of unknown over 7 and solve that problem. Okay, so law of sines works for side-side angle, and that has a couple special cases, but I don't know if I'm really going to get into that in this class. And it also works for angle, angle, side, and it works for angle, side, angle. So those are the 3 situations that happens for law of sines. Okay, so how do we start actually doing some of this math? Let's try this. So here's my law of sines practice, and this is the same sheet again that you want to do. So what we're going to try and do is we're going to try and solve this first one right here. I'll go ahead and zoom in on that one. So I'm trying to figure out x. So these are a pair right here, and these are a pair. So I'm going to write sine of an angle, 42 degrees, that's this one, over its side opposite, must equal sine of the angle, which is unknown, x, over its side opposite, 22. And then I'm going to go ahead and do some cross multiplication with this to try and solve for this. Now you can see that I need to get this x by itself completely, right? So what I'm going to do is I'm going to find out what this ratio is, sine of 42 over 17. I'm going to multiply it by 22, and then I'm going to rewrite it again. So here we go, on our calculators, just like this. You can see this. First thing I'm going to do is I'm going to check my mode, make sure it's in degree mode. We did this the other day, right? So then I'm going to go sine of 42, close your parentheses, divided by 17, enter. That's what that number is. And I'm just going to go ahead and use that. I'm going to multiply by 22, enter. And now I've got 0.8659. So technically right now I have 0.8659 equals the sine of some unknown x. Well, let's go back to our trig stuff before. How do I get rid of sine? Well, that's sine inverse, right? We did this in that first section of stuff. So sine inverse kills sine, and then I'm going to do this. So how do I do this on my calculator? So I'm going to do second sine inverse, and then I'm going to do second and pull up that answer. That's second and the little negative sign down there, right? That says A and S on it. And I'm going to hit enter, and you're going to see that that says 59.98 degrees. So 59.98 degrees. There's my answer. Cool. Now, if I have this angle and if I have this angle, I could subtract those two angles from 180 degrees, and I would get this one right here, right? However, if you look at this picture, does that look like 59.98 degrees? And it doesn't. So it's definitely bigger than that. And here's our first issue, and I wanted to stick you with this one in the very beginning, is that when we have an angle like that we're dealing with, we need to know that our sine of 0.8659 is the same for both of those. So really our 59.98 is the smaller one, and I need to take this one and I need to subtract it from 180. So 180 minus that answer, I'm going to get 120.01 degrees. So this is really 120.01 degrees, because it definitely looks obtuse, right? Okay, so how did I do that again? It's supplement, it's what adds up to 180. So here's kind of why I want you to be able to see this. And this is something that's a little bit bigger in some trigonometry things, but hopefully this makes sense. So watch. The sine of 50 degrees, right, is 0.766. And the sine of 410 degrees is 0.766. Those are both coterminal. They both get you the exact same values, okay? Well, that also happens for angles less than 180 degrees. So if you'll see that my sine of 120 is 0.866, and sine of, let's just round 59.98 up to 60, sine of 60 is 0.866. You'll see that the calculator gives me both of those things to be the same, okay? So if you get an angle, in this case, that when you're dealing with sine and a positive number, it's going to give you the smaller of the two. And then you just have to look at the picture and go, oh, well, that's definitely the bigger angle. I need to use its supplement. Okay? So I'm going to go right here. We're going to do this one and see if this makes a difference. Now, we only had to worry about that first thing on A when we have an obtuse angle. You can see that on B, we don't have any obtuse angles to worry about. So, okay, let's go ahead and try and solve B. So on B, I'm going to go ahead and do this. I'm going to write, this is what I need to find out, right? So that means I need to know this angle. So I have to find out what the third angle is. So I just take those two angles and subtract them from 180 to find out the third angle. So 180 minus 88 minus 35, and I get 57 degrees. So this thing's 57 degrees, and that's pretty easy math so far, right? So then I'm going to go ahead and go here. I'm going to do sine of 57 over x, the unknown side, don't know what that is, equals, and I need to know two other ones. I can't use 35 because look, I don't know the side length over there, and I can't have two unknowns. But I do know these pairs. So then I can do sine of 88 over 44. Okay? So this is the fraction that I'm going to try and solve for right now. And here's my unknown x. So I'm going to do cross multiplication first, like this. And so then I get 44 times the sine of 57 equals x times the sine of 88. So let's go ahead and do this. So 44 times sine of 57, 44 times sine of 57, I get 36.9. Yep. And then I need to get rid of this sine of 88. So I'm going to divide by the sine of 88, and that'll get my x by itself. So 36.92 is what we're looking for. So this x over here is 36.92. And that's a length. And I look at my picture and I go, well, if that's 44, that kind of makes sense. Okay? So that's another one for the law of sines. So let's do one more thing here on the law of sines. And so I've got this one right here. And so I'm going to go, what do I got here? So sine of 51 over 9.4 equals sine of x over 6. And I'm going to cross multiply, and I'm going to solve this one out right here. Do we see that? Because we have to use things that are across from each other. Okay? So let's go ahead and do this. So find out what this ratio is. So sine of 51 divided by 9.4, enter. I get 0.094 times by 6. I get that. And then remember I have sine x equals this number, right? So I have to do sine inverse to get x by itself. So I'm going to do sine inverse of that answer, and I get 34.56 degrees. And then I look at my picture and I go, hey, do you think that's 34.56 degrees? And your answer is yes. And then we don't have to worry about that one in terms of is it obtuse or is it acute? It has to be obtuse. And I simply take, if I want to find that angle, I subtract those two things from it. Okay? So here's the deal, everybody. That's what I need from you. all I need you to do is I need to be able to see the notes that you just wrote down from this, and then I want you to solve these three. So we're going to get rid of all of this. So solve these three using the law of sines. So give a picture, rewrite these three triangles, solve these three triangles for the x's, the sides or angles that are missing, ignore the rest of the bottom of the things, and we're going to count this as credit for law of sines. Okay? But again, you got to stay with me on this, and if you do, we can get through this stuff. Hoping this helps, especially for a couple of you that have specifically asked for things on these ones. Okay?